Bismillahirrahmanirrahim. This is teacher Iman Al-Khaldi explaining for grade 9 from chapter 5 circles. And today we are going to talk about the theorems for tangents to a circle. We need to know first of all some theorems which are theorem number 10, 11 and 12. And these all talking about tangents of a circle. Let's now have an idea about what do we mean by tangent. Definition. Tangent to a circle is a line that touches the circle at one point, which is known as tangency point. And this is clear in the following diagram, which is shown in front of you. Circle and a line. This line touches the circle with one point, which is A. The circle called M, because always we are calling the circle with its center. And this is that tangent, which is the line touches the circle with one point, and A is called the tangency point. Now we are going to have the first theorem, which is theorem 10. At the point of tangency, tangent to a circle is always perpendicular to the radius. And we can see this in the following diagram, which is clear in front of you. Now you have a circle called M, and this radius is perpendicular to the tangent AB. Or you can say that the tangent AB is perpendicular to the radius, and sometimes it is perpendicular to the diameter. It can be written in that way, the line MC perpendicular to the line AB. This is the radius perpendicular to the tangent, or you can read it, the tangent perpendicular to the radius. Now let's have some examples, and after we're going to take theorem number 11. Theorem number 11, from one external point, two tangents are drawn to a circle. Then they have equal tangent segments, like AB equals to AC. And you can see this clear from this diagram. You can see that here you have the point A. It is an external point to that circle. That means it is outside the circle. And we draw from it two tangent segments, and they should be equal to each other. That means they have the same lengths. Like, for example, we can say that AB, if it is equals to 3 centimeter, AC, it is also equals to 3 centimeter. And that will make the whole triangle AMC with ABM are congruent because all sides are equal and or angles are equal. Here, BM starts from the center M, so we call it radius. And MC starts from the center M, we call it radius. And the two radii are equal. And these two tangents are equal. And we know that from theorem number 10 that the tangent AB is perpendicular to the radius BM. That will make this angle B equals to 90 degrees. And similar, AC as a tangent is perpendicular to the radius according to theorem number 10, and that will make the measurement of the angle C as 90. Now, this is 90 and this is 90. If you add them, you will get 180 in a quadrilateral. A quadrilateral means a shape with four sides. And if the opposite angles are supplementary added up to 180, that will make the whole shape, this quadrilateral, cyclic. Cyclic means that we can draw a circle passing through the four vertices. like that. Another circle, different than what do we have, passing it through these four vertices. Then all opposite angles are supplementary. We can have more examples. This example is talking about theorem number 11, which is clear in front of you. If you have the measurement of A is 70, you need to find the measurement of A, B, C, and BMC. Because you know that the shape here, which is ABMC, is cyclic quadrilateral, so you can say that here, this B is 90 and this C is 90, and you can imagine that the shape is cyclic quadrilateral, so opposite angles are supplementary. Similar, here this 70 should be added up to that measurement of angle M to be 180 because it is in a cyclic quadrilateral. That will make the measurement of M equals to 180 minus 70, which is 110. So this is how to find it. But to find the measure of ABC, ABC, try to think about what type of triangle is ABC. You can see that it is an isosceles triangle. Why? Because the side AB is equal to the side AC. That will make the two angles are equal. So you need to subtract from 180 this 70 to get 110 divided by 2 to get 55 degrees for each. That means that the measurement of angle ABC is equal to the measurement of ACB in isosceles triangle. And to find the angle, which is M, like we said before, in a cyclic quadrilateral, it should be 180 minus this 70, and that will make it 110. Let's have more ideas, which is the following. Example, choose the correct answer. You have that shape, and it is from before. You can see that this tangent is perpendicular to the radius always. And this tangent SR is perpendicular to the radius SO always. That means they are making 90 degrees. 90 and 90, 180, that will make that shape TOSR cyclic quadrilateral. He is asking now to find what is the size of the angle SUT. SUT, which is that angle. It is an inscribed angle, which is circumference angle in another way. And the relation between the inscribed angle and the central angle is the half. The inscribed angle measurement is half the central angle if they share the same arc. So we need to use the 40 degrees at R and minus it from 180 to get the central angle in the cyclic quadrilateral, and that will make it 140. Then take the half of it, which is going to be 70. So the answer finally is going to be C at 70. And this is the way how we calculate it. Now you can have another theorem, which is theorem number 12, which is the last for today. You can see that theorem 12, we can call it alternate segment theorem. And it is called alternate because you have an angle to the right and an angle in an opposite position to the left of the segment chord. So the theorem is saying an angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment, or we can call it the tangent chord theorem, which can be as The angle between the tangent and the chord between the tangent and the chord is equal to the inscribed angle subtended to that chord from the opposite side. And this is theorem number 12, and we can have some ideas about it. You can see that this diagram shows the alternate segment theorem. In a short way, the red angles are equal to each other, and the green angles also are equal to each other. Look, because they have the same property for this theorem, the green one. Now let's have some examples. You can see that from this diagram that the angle, which we call it BAD, is equal to 45 degrees. And we need to find the measurement of the angle ACB, which is x degrees. To find it, according to theorem A12, it is equal to that angle, which is BAD, 45 degrees. They are equal according to theorem A12. Let's have one more example, which is according to that diagram, he gave you DAB is 40 degrees. And you can say that the angle C is 40 also, according to theorem 12. And at A here, you can see that at BAC, the measurement of this angle is 65. To complete the measurement of the straight line, which is 180, you will add 40 plus 65 and then subtract it from 180 to get 75. And that will make this angle between the tangent and the chord is equal to the inscribed angle drawn on the or subtended to the same chord in the opposite side. So the measurement of x is 75 degrees. Thank you for listening. And if you have any question, you can ask or write your comment. Don't forget to subscribe, share, and do like. Thank you very much. See you with the next theorems 13 and 14.